as a continuation of what was started yesterday as daily practice questions 4 to 5 every day uh, towards preparation for NEET. We can take up the sixth question. Two identical induction coils, each of inductance L, are joined in series, placed very close to each other, such that winding direction of one is exactly opposite to that of the other. What is the net inductance? See, in this case, when two coils are joined in series and they are placed very close to each other, such that winding direction of one is exactly opposite to that of the other. See, in this case, what happens? The EMF produced by the first coil is 180 degrees out of phase with the EMF produced in this second coil. Therefore, what happens is the net inductance. So the net inductance, see, for the first coil, the net inductance will be negative, and for this second coil, the net inductance will be positive. So if you just add this, the net inductance will be 0 in this case. Okay, so that is fourth option. Let's take the next question. Question number 7. It is assertion and reason based. Assertion says gravitational force inside a hollow spherical shell is 0. This is true. Inside a hollow spherical shell, there is no gravitational force. So assertion is true. Second is, according to the shell theorem, a uniform spherical shell of matter attracts a particle that is outside the shell as if the shell's mass were concentrated at its center. This is also true. So if we have a spherical mass, okay, and if you want to calculate the force on this particle, then it will be Gmm upon r square. So the entire mass of this sphere, we assume it to be concentrated at the center. Measure the distance from the center. So this is also true. Assertion is true and reason both are true. But assertion is not the true explanation of the reason. Therefore, if you can just go through the options, think option B is correct here. Okay, let's try to solve question number 8. This is also assertion and reason. Statement A, statement B type. Okay, so statement A says force of attraction due to hollow spherical shell of uniform density on a point mass situated inside it is always positive. See, if you just refer the previous question, we know that there is no force of attraction on a point mass which is situated inside the hollow spherical shell. So statement A is wrong. Second, the force of attraction between a hollow spherical shell of uniform density and a point mass situated outside it is same as if the entire mass of the shell is at the center of the shell. This is also very connected to the previous question. See, this is true. So statement A is false and statement B is true. So we can see that here statement B is true and statement A is false. So C should be the correct option. Okay, we'll go to the next question. Again, a question on gravitation. A ring has a mass m and radius capital R. Distance of the point on its geometric axis from the center at which gravitational field is strongest. Okay, so here we have a ring. Okay, we have a ring of radius R, something like this. So this is the ring. So this is having radius R and at a distance x on the axis of the ring. Distance of the point from its geometric axis from the center. Okay, so here, see here, the gravitational field, it's a very standard relation, Gmx divided by r square plus x square whole raised to 3 by 2. And the direction is towards the center. Okay, So this is a ring, mass m, radius r. So this is the field. This is the gravitational field. Now this is strongest at the field is maximum. Field is, it's a very standard answer. Field is maximum at plus or minus r divided by root 2. Okay. So if you let's just look at this, option D should be correct. There is a similar question in electrostatics also. Electric field because of a uniformly charged ring, mass m and radius r. There also we have electric field maximum. The location is r by root 2 only. So very similar to gravitation. Okay. Question number 10. A body of mass 2 kg is moving with a velocity, uniform velocity of 5 meters per second on a smooth horizontal surface. Constant horizontal force of 4 Newton acts in the direction of motion for 5 seconds. What is the final velocity of the body? Another question from mechanics. So here we have a mass of 2 kg. It is moving with a uniform velocity of 5 meters per second. So velocity is constant until there is a force acting now. Okay, now this force, see, force will change the velocity. Okay, and therefore the body will be accelerated. So this force of 4 Newton, it is acting on the body for 5 seconds. Okay, so because of this force, there will be acceleration in the body. So first we can calculate acceleration of the body. Acceleration is force upon mass. So that is 4 by 2. So that is 2 meters per second square. Now what is asked here, the final velocity of the body. See, initial velocity is u, that is 5. Acceleration is 2 and time is 5 seconds. So final velocity v is equal to u plus at, which gives us 5 plus 2 into 5, that is 2 plus 5 plus 10, that is 15 meters per second. This is the final velocity of the body. If you just look at the options, we have second option.